Hello dear students, good morning all of you. Today we want to start with some questions related our unit, that unit and measurement. Okay. Previously we have done some question of physical world, then today we will do some question related our unit and measurements. Okay. Now we are starting beta. We have done previous classes unit and measurement, quantity, then we have done the significant figure, and after that we have done the error and type of the error, and that error coming during the experiments in our lab. Okay, different type of the error we have done, which error, which type of the error possibility will be there in our experiment. Now today we are doing some questions related with these topics. Our first question we are starting: the number of the base units for measuring physical quantity according to the SI system. Okay, our base unit, that is fundamental unit. Yes or no? We have done there. We will revise with these question also our unit fundamental units. Yes or no? We have done there two type of the units, that is here fundamental units and derived unit. Okay, then fundamentally we have done beta, there is a 7 type of the unit which in our nature we can't derive these unit from the another units. That's why we are calling it base unit, fundamental unit. Okay, then our dimensional formula also coming from these here fundamental units only. So here how many units you have done? Remember there we have done beta 7 type of the fundamental units. So see your option 1, that is A, wrong. Then next your 4, this also your wrong. Third will be 7, that's why this one option our right option, fundamental base units our having 7 units. Okay, now next question: what is the unit for measuring intensity of the light? Intensity of the light beta, this is also one of the fundamental unit. Okay, 7 type of the fundamental done: mass, length, time. Okay, then out of these 7 units, then 1 our fundamental unit, intensity of light. Okay, then here asking what is its unit, then its unit beta candela. Yes, this one first answer our right option. These light year not having any unit. Light year is a distance for the light coming from sun to our earth, that is distance is known as light year. So this one our light year. Next Newton, no, Newton is a force, is the unit of the force. And next your mole is not your unit of the mole, that is unit of the mole. Okay, so these all are wrong option. This one first our right option. Now next question, our what is the full form of the SI? Yes or no? I told you beta full form of the SI, that is a system international. What is the need of SI? There is a different our unit of the system, that make MKS. Yes or no? CGS, FPS, these are the different units of our system, but SI is a different from these systems of the unit. Yes or no? What is the need of this system of the units? That these units, MKS, CGS, then is the countries using these type of the unit in a different way. That's why one term is there, that internationally we can use anywhere we want to go, then they can understand what is unit of this one. That's why we have taken one term, that is SI unit. Okay, so SI unit, full form of SI unit, that is not standard international. This one next our system international will be right option of the full form of the SI. Okay, these are the wrong option. Next our question, convert 5 Newton to dynes. Okay, that we have done, how we have solved also already in your dimension analysis. That is 1 Newton equal to your 10 raised to power 5 dyne. Yes or no? This one we have done proof of this one equal to this one. Here in your question given 5 Newton equal to how many dynes are there? So 1 Newton is equal to this one. So 5 Newton we can write there, that will be 5 into 10 raised to power 5 dynes. So write which one option will be right. Check here. This one here, 5 into 10 raised to power 5. There 5 zeros are there, so we can write there 5 into our first option only right option. Next here 500, this one wrong. 5 dyne, this also wrong. point something is there, then this also our wrong option. So first our will be right option. Okay, now next question our will be, what is the unit of the measurement of the solid angle? Okay, we have done better two type of the supplementary unit. Remember, supplementary unit, supplementary unit. We have done two type of the supplementary unit. Supplementary units, two type. One hour told you, that is here plane angle, plane angle, and second one our solid angle. Yes, no? Plane angle, solid angle. Okay, then unit of the plane angle our radian. But radian is a unit of our plane angle, and solid angle we have done beta stadian. Okay, of the major our stadian. Which one is right? Degrees, that is wrong. Radian, radian is not unit of solid angle. This one is a unit of plane angle. Last one here, grade, grade is also not unit of any quantity. So here stadian our right option, that is the unit of. Next your question, that some quantities are dimensionless but having unit. Is it possible? Means some quantities are having unit, not having dimensions. Dimension we have done that in form of your MLTs form. In square bracket we are writing their MLTs. If there some power is there, then we can write, otherwise we will keep 0. Okay, in your question is given beta having unit. Can it is possible any quantity is having unit but not having dimension? Yes or no? Okay, so this one our true, not false. This one true. Yes, it is possible. Is it possible? Yes, it is possible. Any example can you tell me? Example beta this one. For example, these only plane angle, stadian angle. Okay, solid, radian and stadian. These are the unit of the plane and solid angle only. Okay, but we can't write these units in form of the dimensions. Okay, so here we can write the, it is true. Example we can write which quantity, those having dimensionless but having unit, you can write their plane angle, plane angle. Okay, solid angle, solid angle. Okay, these are the quantity whose unit are there but they are the dimensionless. Okay, yes, but our next question, our sixth question written that some quantity are the dimensionless but having the unit. Is it possible? Means some quantities we have a different type of the quantity, that is our physical, non-physical, that is fundamental derived unit. Then these fundamental derived unit, then out of these all quantities having unit, but they are dimensionless, having dimension, not in form of your in form dimensionless and having unit. Is yes beta, it is possible. Okay, in question asking any, yes beta, it is possible. Okay, in question asking any quantity is there having having unit but there is no dimension. Dimension means that is form of the MLTs. Okay, so here beta two example is plane angle, solid angle. These are the quantities which are having unit but not having the dimension. Okay, we can't express this radian, its unit is radian, and solid angle its unit is stadian. these are having unit, but we can't write in form of the dimension. That's why we are calling it, these quantity are having unit but not having dimension. So yes, this one our true, this one first option our right option. Okay, next our question, that is, if PQR are physical quantities, here given PQR are any physical quantities having different dimension, which are having different dimension, then which of the following combination can only be meaningful quantity? If PQR are the different quantity having different dimension, different unit are there, then which one is a meaningful quantity? Here three option are given, beta, more than one is possible. Then out of three, you have to check if PQR we are taking the different units, then which one relation can be meaningful. Okay, then we know that if PQR or all three are the different units, for example, its unit is force. Okay, its unit is our meter. For example, its unit is our time. Okay, so like this one, these different unit, different dimension we are taking of PQR, then we can write like this one form. Can you write like this one form? Means P minus Q. Can you subtract one different unit from the another unit? Can we subtract from F minus M, force minus M, divided by your meter? No, because here we can beta add, we can subtract with the same dimension only, same unit only. If your quantity having same dimension, then we can add those quantities. If having the different dimension, then we can't add, we can't subtract. Okay, so your different quantity, let me assume this one. These we assume their P is stand for the force, let your Q stand for the meter, and R stand for the time. Can you write this one in this form? Can you subtract force minus meter? No. Is it no possible, beta? For the subtraction addition, both are having the same dimension, then only we can subtract from this to this. Okay, here any force number will be there, then you can subtract beta force only. Force means Newton. You can subtract Newton to Newton only, then we can solve it. Otherwise, it will be wrong option. So see our beta P minus Q by Q, different dimension P and Q. That's why it is not possible. We can't write like this one. It is a meaningless. Next, our PQ minus R. Here also beta same. P stand for the Newton. Force is there. Q assume there, if meter will be there, then we can multiply both quantity. We can multiply beta different quantities, but we can't add and subtract. Next, our R we have assumed beta time. So for the time, we can't subtract this one Newton meter minus second. We can't do it because I told you beta for the addition subtraction, we can't take the different quantities. So here all should be having the same dimension, then we can write like this one, but it is our meaningless. Now see our right option, next option PQ by R. Yes, beta here in this one option not having any addition, not having any subtraction. That's why this one our right option. We can multiply, we can divide different dimension. So here this one C option will be right option, and more than one of the above this also a wrong. That is your only one option our right option. Understood? So remember this thing beta, we can't add, we can't subtract different dimensions. We can add and subtract only same dimension only. Okay. See beta next one, which one of the following is a dimensionless quantity? Okay, here given your mass and here refractive index, plane angle. Which one our dimensionless quantity? Okay, mass, no, it's having dimension because we can write its unit as kgs. Okay, then next here refractive index. Refractive index beta already we have done in our 10th class in optics we have done. Yes or no? Remember, refractive index is the ratio of the speed of light in one medium to the second medium. Okay, we have done beta this one relation in our 10th class. Refractive index is equal to speed of light in one medium to the speed of light in the second medium. Okay, light is entering from one medium to the going in the another medium. So here first one medium, second one medium, then speed of light will be changed as medium will be changed. Yes or no? So ratio of the speed of light, that we know, we will call it refractive index. See here beta, upper side also speed, downside also speed. So ratio we will find then the speed meter per second. So units will be cancel out, these units will be cancel out, meter per second, downside also meter per second, then it will be our unitless. Yes or no? So refractive index will be our unitless, second option will be our right option. So plane angle, this one also wrong, because here no, not wrong, plane angle. Plane angle beta, this one I told you in your previous question that plane angle is having unit. Here given a beta dimension less, not unit less. Okay, refractive index is a unit less. Okay, but plane angle is unit less but not dimensionless. Here asked that is your dimensionless. So plane angle also will be our right option. Both B and C will be our right option. Okay, plane angle having unit but it is our dimensionless. Clear? So now our next question. If V stands for the velocity, L stands for the length, T for the time, M for the mass. Okay, then what is the value of x in this equation? Here this one relation is given, but then you have to find what is the value of the x. How you can find dimensionally beta, we will write the unit of each term, then check there. Both side, I told you beta dimension analysis, both side, left hand side should be equal to right hand side dimensionally. Yes or no? Dimensionally. In dimensionally analysis, we have done a huge application of the dimensions. Then any equation is written, then you have to check that is dimensionally right or wrong. So both side beta we will check, then they should be equal with each other dimensionally. If not equal, then we can't write that relation. So in your question, this one relation is given, then you have to check that is dimensionally right or wrong. So first one, your length is given. L stand for the length. Length will be your meter unit. Yes or no? Meter. So this one completely another side also should be equal to meter only. We have to take value of x like this one, that completely will be equal to meter only. So how you can write there beta? Velocity. First our V stand for the velocity. We know about this one velocity. Velocity is our meter per second. Yes or no? Know everyone about the velocity? Okay. Displacement per unit time is known as velocity. So displacement is meter, per unit time will be second. So its unit we can write there meter per second. So time unit we can write there second, and divide by your mass. Mass is your kg. Yes or no? Okay. And here power is given beta x. This x you have to find out. What value you will take here, that it's come equal to your meter only. So check here beta, second to second cancel out. Here should be left meter only. That's why if we are taking its power 0, then we can call it 1 only. Yes or no? Here left beta meter by kg raised to power x. Yes or no? If we are writing here m kg, its power we are writing 0, then any term is having power 0, then we will write 1 only. Okay, so here left here 1 only, then here left here meter only. So dimensionally this side should be equal to this side meter only. So here if this one possible, if we will keep the value of x equal to 0. So here first option, check here where is 0. See here first option 3, this one are wrong. Next option here 2, this also wrong. Next 1, this also. Now your last one D option is 0. That's why our this one option is right option. Clear to everyone beta? Dimensionally keep in your mind beta, any equation will be given, then all equation always in any unit you are doing, any chapter, anywhere you are checking that this one equation is right or wrong. So first one beta, write dimensions. Okay, dimension both sides should be equal. If you are taking one side you are Newton, then another side always will be Newton only. Okay, one side you are taking Joule, then another side also should be equal to Joule only. If not coming equal, that means your equation is wrong, you are not writing right equation. Okay, so our next question, assuming standard notation, which of the following quantity is dimensionless? Okay, here B is a velocity, A is acceleration, P stands for the power, F stands for the force, and E stands for the energy. Okay, here given your different option, you have to check which one quantity is dimensionless. We have to write the dimension of each quantity, then solve these quantity which is coming dimensionless and which are having dimensionless. See your first option beta, one by one we will check this one. Velocity divided by acceleration. Velocity is our meter only, divide by your acceleration. So meter per second our velocity, divided by your meter per second square is our acceleration. So you can write there it is dimensionless. No, meter to meter cancel out, then here left here second only. Yes or no? You will solve this one beta, then it will become second. So second is a time unit. So this one is not a dimensionless. Its dimension will be equal to beta M0 L0 T1. This yes, beta, we have done. That is your first one option, velocity by acceleration. That is your dimension, having dimension M0, L0, and T. T, M0, L0, and T raised to power 1. This is our dimensionless. So this one our wrong option. Here we have to find out beta which one quantity is the dimensionless. So next quantity, our power by your force per unit area. We know about this one. Power equal to your force into velocity only. Yes or no? Know about this one relation, power equal to force into velocity only. Okay, so how we can write this one relation? Remember how we can write power? Power, we know about this one, power beta, that is rate of doing work. Yes or no? Rate of doing work, and work we know about this one, force into displacement. Yes or no? Work is force into displacement divided by time. So displacement by time we can write it velocity. So here we can write with a power equal to force into velocity. So right here upper side also this one your F by V, downside also your F by V, then unit of both side upper and down will be equal, cancel with each other, then it will give you unitless. If this one your unitless, then this also should be your dimensionless only, dimensionless. Okay, so here we have to find out which one is a dimensionless. Our B option is our right option, this one our dimensionless. If you want to try this one, force into energy by length, this also no dimension, because your force unit is your Newton, energy joule per unit length will be meter, this also not your unitless. If you not unitless, then dimensionless. Next your velocity per g, g is the acceleration due to gravity, so this also will be our dimensionless. Okay, thank you. कितनी देर का हुआ?